is there life at all? How is it done? What's going on here? Why am I here?
Where did we come from?
Look at quantum physics.
An immense quantum mechanical iceberg of possibilities.
Quantum mechanics allows
The emotional response is a great mystery.
The brain does not know the difference between what it sees in its environment and what it remembers.
We are running the holodeck.
Whatever way we observe the world around us.
Are all realities existing simultaneously? Is there a possibility that all potentials exist side by side? Have you ever seen yourself through the eyes of someone else that you have become? And looked at yourself through the eyes of the ultimate observer?
there's a physical reality that is absolutely rock solid, and yet it only, if you want to put it this way, it only comes into existence when it bumps up against some other piece of physical reality. That other piece may be us, and of course we're partial to those moments.
So, what they taught us in school isn't really the way it is, and that our senses are playing tricks on us. You just gotta wonder, what is this reality that we find ourselves in? Quantum physics says it's all just waves of information. Do I believe that? I hope so. Yikes! And here we are, the granddaddy of all quantum weirdness, the infamous double-slit experiment.
The first people who did these experiments, and these experiments of, experiments, crude experiments of this kind, were first performed almost 50 years ago, or more, 60 years ago. Those people were flabbergasted.
To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands. Good so far. Now, let's go quantum.
This is just to break down your prejudice that says a particle is a particle. Now you got to understand it's a particle and a wave.
An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like the marble, a single band. So, if we shoot these tiny bits through two slits, we should get, like the marbles, two bands. What? An interference pattern. We fired electrons, tiny bits of matter through. But we get a pattern like waves, not like little marbles. How? How could pieces of matter create an interference pattern like a wave? It doesn't make sense.
You got to understand it's a particle and a wave. Now that you've taken that leap, let's get one step closer to the reality. It ain't either of those either. And it's both at the same time.
But physicists are clever. They thought, maybe those little balls are bouncing off each other and creating that pattern. So, they decide to shoot electrons through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like a particle. But mathematically, it's even stranger. It goes through both slits, and it goes through neither. And it goes through just one, and it goes through just the other. All of these possibilities are in superposition with each other.
We did these experiments, and we got certain results. And in the light of these results, we asked a question of the form, gee, which path could the electron have taken through this two-paths apparatus? And if there are two options like that, it's just a matter of standard classical logic, there are four logical possibilities. A, B, both, neither, okay? We went through those possibilities one by one and designed an experiment in each case to test that possibility. And the answer in each of the four cases was negative. So we can systematically, piece by piece, eliminate all of the four logical possibilities, okay, given the assumption that it makes sense to ask the question, which route did it take?
Physicists were completely baffled by this. So they decided to peek and see which slit it actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched.
So the electron is very peculiar. The electron is very peculiar in the sense that when you are not looking, electron can be here, can be there, or can be over there in the corner of this room. It can be all over this room, so to speak. But whenever we look, this is the strange thing about these electrons. Whenever we look, we always find them to be in one particular Geiger counter, although we may have a room full of Geiger counters. We never hear the Geiger counter sticking all over the room. This is the fundamentally important stuff about the electrons.
It was here that physicists stepped forever into the strange, never-world of quantum events. What is matter? Marbles or waves? And waves of what? And what does an observer have to do with any of this? The observer collapsed the wave function simply by observing.
We are always the observer. But sometimes we identify with the event so much so that we even lose the aspect of the observer. That's why the materialist gets totally lost and thinks that we could do without the observer.
In tiny corners of space and time, scientists found unfathomable energy and mind-numbing mysteries. Mysteries that suggest we are all connected, that the physical universe is essentially non-physical. Time and space are just constructs of this non-materialness.
I like to think of space as empty and matter as solid. But in fact, there is essentially nothing to matter whatsoever. It's completely insubstantial. Take a look at an atom. We think of it as a kind of hard ball. Then we say, oh, well, no, not really. It's this little tiny point of really dense matter right at the center, surrounded by a kind of fluffy probability cloud of electrons popping in and out of existence. But then it turns out that that's not even right. Even the nucleus, which we think of as so dense, hops in and out of existence just as readily as the electrons do. The most solid thing you can say about all this insubstantial matter is that it's more like a thought. It's like a concentrated bit of information. Modern materialism strips people of the need to feel responsible. And often enough, so does religion. But I think if you take quantum mechanics seriously enough, it puts the responsibility squarely in your lap, and it doesn't give answers that are clear-cut and comforting. It says, yes, the world is a very big place, it's very mysterious, mechanism is not the answer, but I'm not going to tell you what the answer is, because you're old enough to decide for yourself.